run this flask into the test tube. Now, one thing that I find out is that actually when I had these slants made of water, this one actually holds 10 milliliters, and in order to achieve the same result, I end up adding 8 milliliters or so of media. The difference of this is just because the media is more denser than water, so it takes less volume to achieve the same height. And if you don't believe me, ask your physics professor. But at least empirically speaking, I tested. Now, in order to autoclave your media to make it sterile, you have to put your caps that loosely fit your test tubes, and then you have them in your racks, and then you have to, in essence, go to the autoclave, put them there, and since I have it in one edge, so when I was dispensing this media, I had this template of water on one side, and I used it to go basically across these empty tubes to have like an eye level into where to go, but I don't want to have them on the edge, so I'm going to put them here on the center of the rack, so it will be more stable in terms of one edge being of almost equal weight as the other one, so it doesn't tip over, which if you're careful it shouldn't be. So anyway, out of that 100 milliliters, then because I added less volume, I end up with around 13 test tubes. And if you see, well, I'm not going to sterilize this water, but if you see how this media already solidified at room temperature and how it stayed like that, so we don't want it like that. So once we put in the autoclave, it's going to, of course, liquefy, and then it will be in autoclave for 15 minutes, 121 degrees Celsius at a pressure of 15 psi. That will liquefy. So when you take it out of the autoclave, it will be liquid again, and then you put it on the tube holder that makes the slant, and you have a slant. Now, sometimes you have semi-solid media that is half broth and half agar, as I told you today in lecture, that is called a dip. So we might use dips in this semester, but we might not use, but the dips in essence look like this. So it has a flat horizontal edge, but we want to have kind of an angulated edge, which we're going to reach once we autoclave it. Anyway, so let's go here to the autoclave. So we have in this prep room, and we have here 2 autoclave machines. So these are specialized equipment. You will put your materials that you need to autoclave here. We have a chamber, and we have here this drain that it has a valve, and I close the valve to add water. We add the still water, and then we have to add the water up to this edge on the opening of the chamber. This water, with the high temperature and the pressure that you build inside, is going to create a moisture environment, which is going to penetrate into the inside of the tubes. It's going to melt the agar, and it's going to kill all forms of microorganisms, making it sterile. And then you have to close the lid, which has a seal, and you pull it, and then it has this little clasp that goes into this metal holder, and then you push all the way until you feel resistance, meaning that you seal your chamber. Now here we have all the indicators for how to operate this. So here we have a reset button just in case that something happens in the middle of the process and then you want to stop the machine from working. We don't use that. We do everything correctly. This is a low water indicator that if you don't add enough water into this chamber, then it will tell you, you know what, I need more water to create or build the pressure, 15 psi. pounds per square inch. And then here it's an indicator of the pressure that it reaches. And here we have the temperature for different types of materials. We use 250 Fahrenheit, which is the equivalent to 121 Celsius. And here is the temperature dial. So this will move into 121, which is already set for us. And then this is the timer. So with this, you just turn on the knob into whatever time you want to sterilize. So we will use for 15 minutes. And this is the exhaust knob, which you can make the exhaust, or once you finish sterilizing the vapor, steam, or the pressure, to go fast or slow. Since we are sterilizing liquids, you want to have a slow exhaust. You don't want to depressurize very fast, because as you're depressurizing really fast, you will lose a lot of water. So you want to do the slow exhaust. Now, if you were using materials like gauzes or metals that can be corroded by being exposed so much time for moisture, then you would use the pulse exhaust. And in the slow exhaust, it will take around 1 hour after you sterilize the material to completely depressurize the system. You cannot open this machine when you still have pressure in the chamber. First, you cannot open it. If you try to open it, it's not going to let you. And if you force it to open, all that pressure, all that vapor is going to go into your face, and it's going to burn yourself. And once this is done, once the pressure is into zero, once the temperature is lower than 160 degrees Fahrenheit, then you can open it. And then you have to have your thermal gloves in order to open it. Once this is running, because this is the demonstration, and once it's finishing, I will make another video where I show you the end result, and I will show you how to put them into these slants, into the two holders to make the slants, and then I will be done. Bye-bye.